Gosh, all right, like I messaged, let me talk again. Okay, just like I messaged you, I'm just gonna do this first page. My brain is literally fried. That will give you a big start, and then I'll either have the rest of them up later today or really early in the morning. And by really early, my early is not like 9 o'clock. So I'll get these to you, I promise. With you having a due date till Friday, I'm not overly concerned. But I definitely will get these up to you. What we're not going to have right now is just like this general solution stuff, which is really not that difficult. And then I'll go through and do all these. I might take a problem or two off because like this problem's kind of difficult. So I feel like I'm going to confuse you more if I do that. And then there's obviously a word problem in the back. So there's quite a bit on these notes. I will get them to you, I promise. Just let me take a brain break because it's 3:30 and I'm way behind. Okay. So warm up on number 4. If you remember, the first thing you can do with that forge, you can actually kick it out. Okay, so it leaves you with this. And this is actually an inverse tangent problem. So you really have inverse or 4 times inverse tangent of x and then -1 and 1. And you can do this stuff in your calculator or you can do your unit circle. And obviously I can't show you. But there is a way to do the unit circle in here. Basically, you plug in 1 and you find where tangent is 1, and that's your answer. And then you plug in -1 and you figure out where in the unit circle tangent is -1, and that's your answer. So when you plug in the 1 into tangent, or you find the answer of where tangent is 1, you get pi over 4. And when you plug in or find where tangent is -1, you get negative pi over 4. So the 4's cancel, leaving with pi minus negative pi. So the answer is 2 pi. Okay. So differential equations actually can be a college course just outright on its own. We're just going to just dip our toe in it just a little bit. That's pretty much all we're going to do with it. We're not going to do a whole lot because it is an entire course in college. And the one strategy to doing this is called separation of variables. Did I ever outright know that that's what it was called? No, I didn't know that until I started teaching it. But basically what it means is I'm going to get the x's and dx on the right side and the y and the dy on the left side, and then you're going to integrate it as you know. So my problem with this is I tend to move a little bit faster than I should, so I'm probably going to need to pause the video at some point. So I want to get the y to the left side, so I'm going to multiply by y. I'll take this as slow as I can. So it gives you y dy over dx, equals x squared. And I want the dx on the right side, so I'm going to multiply both sides by dx, leaving you with y times dy and x squared times dx. You don't really need to put the multiplication signs, but they're there. And it should kind of remind you of integrating it, and that's the next step. So after you do this, you're going to integrate it. I'm going to write that step down here so you have it better in your notes. And you integrate both sides with respect to whatever it is. So we're going to integrate that with respect to y, and you get 1/2 y squared. Now technically it's plus c because we don't have, it's indefinite. We don't have numbers right here. And then we're going to integrate that, and that gets 1/3 x cubed plus c. So then at this point, the whole job, I'm going to separate something real quick, give me a second, is to, I covered that up, is to solve for y. Okay, so I'm going to make a line here to separate our work. So we need to go up here and do that. So the first step you do is move the c over, so you'd subtract c. And a lot of people make the mistake of, because it's confusing, is the constant minus the constant is 0. Well, we don't know what this constant is, this constant is. So it really just becomes c. So we're going to notice on 2 and 3, we're going to do things a little different, and we're not going to add the plus c into here. If you hear that noise, that's my cat trying to get into the cupboards because he's annoying. So we won't do this step again. I'm just trying to show you something. So when you move the c over, it's really just c. It's weird. Okay. We don't know what that value is, so it's still just some kind of constant, and we just make it plus because we can. All right, so then we have to get this 1/2 over, so we're going to multiply everything by 2. Oh, there he goes again. It's my cat. And when we multiply by 2, we get 2 over 3x squared. And it's not going to be 2c. It's just going to be c again because it's just a constant. We don't need to multiply 2 times c. 2 times c is still just the constant itself, whatever it is. So we don't have to do that. And then we're going to get rid of the square, so we're going to square root it. And that gets us plus or minus the square root of 2/3 x squared plus c is underneath that. And we're going to leave it just like that. And that is our final answer. So basically what you're trying to do is figure out what the original was. And that is right there, without knowing what the c is, of course, or if there is even a c. Now, because of this x squared is under a square root, you cannot simplify it because of this plus c. Anything added or subtracted completely stops that process of simplifying that, so don't do it. All right, moving over to 2. You're going to notice that on 2 it says y prime. Well, we should know that that's the same thing as dy over dx. Correct? Okay, correct. So we have to get y on one side and the dx to the other. So we're going to multiply by y, which gives us y dy, and we're going to multiply the dx over. And from there, and I'm going to write it this time, we're going to integrate. Okay, so we're not going to write the plus c over here, so we don't have to worry about that confusion. We're only going to put the plus c on the x side. So the integral of y is 1/2 y squared, and the integral of 2x is just going to be x squared plus c. So we're only putting the plus c here. We're going to multiply by 2, so this is a lot like the other equation. And you just get 2x squared plus c. Oh my god, he's annoying. And then we're going to square root both sides. So you get plus or minus the square root of 2x squared plus c. And that's it. That's that answer. Okay? And the last one I want to do for this video, and then I'll get more on here as soon as I can. Okay? And let my brain kind of survive. Oh my god, that's my cat. So the last video I had to deal with Noah, and now I'm dealing with my cat. He literally just keeps opening and closing the thing. I wish I could show you. Oh, he just smashed his head. Nope, he got through. So now he's going into my cupboards. Awesome. We're just going to let it go. And so we're going to get the y squared over here. So to get the y squared over, you actually have to divide. So we really have 1 over y squared dy, and then we'd have sine of x times dx. And we know that y squared in the denominator is the same as -2. So I'm going to write it this way. And we're going to integrate. So the integral of y to the negative second power is negative y to the negative first. And the integral of sine is negative cosine of x. And then we're going to add the c. Now, we're going to divide and get rid of the negative. So you divide everything by -1, which makes that go away and that go away. But the plus c, it's still some kind of constant. If it's a negative constant, then it would change the subtraction. If it was a negative here, and then the constant was negative, it would make it a negative and negative, and so it's a positive. So we keep it as an addition, so we don't change that sign. And then I'm going to rewrite this as 1 over y equals cosine of x plus c over 1. This whole thing is over 1. Okay, that's the weird part about it. So you can like cross multiply and do all that jazz. I want to go like this, so actually no, I'm not. But there's no need to. You can actually just, you're basically multiplying everything to that negative first power, and that flips the y up, and you get 1 over cosine of x plus c. This is a whole unit, so it has to be the whole thing over 1. So it doesn't become 1 over secant of x plus c, which is weird. So that is your final answer. So that's kind of a hint into differential equations. I'll finish the videos and get those up as soon as possible, right? So this is the first video. Up in the left-hand corner will be the link to the next one, so follow that. Thanks, bye.